Alright guys, hey, how's it going? So I got another video for you today. We have here, this is the MSI MAG B650. This is the B650 Tomahawk. Got this off eBay for 35 bucks. This thing's like brand new. I can only see one screw that they put in, so there's like one screw there. Everything else is literally completely untouched. Like, this motherboard is pristine except for that. So let's take a look and see what we got here. All right, so as you can see, it's got some pretty good pin damage. Let's see if we can angle it a little bit. Yeah. So somebody must have dropped a CPU on here or something. Either that or they dropped their cooler on it, or possibly a screwdriver or something. I don't know. So either the CPU, screwdriver, or their cooler or something hit it. But yeah, it got hit pretty good. So anyway, so I got this motherboard for dirt cheap, and today we're going to remove the socket and hopefully get a new socket soldered on. And I don't know how easy it'll be, how difficult it'll be. Motherboards are usually a challenge to heat because they're so big. Plus with all the components on here, they kind of have a little bit of a flex to them. I don't know. We'll see. We'll see what we can do. So I'm going to go ahead and prep the motherboard so I can remove the socket here. And then we'll try to get this inner socket removed. All right. So I found a bit that will work. I'm going to go ahead and just get this top plate off here. I'm going to start tearing this down a little bit. Here, let me move this out of the way just a little bit. I'm going to take this. Hope these screws aren't captive, which I think they might be. Oh shoot, yeah, maybe not. All right, yeah, it looks like the screws are captive, so I'm just gonna keep this off to the side. We don't even need this right now. So this is the little suspension, little holder bracket. So we're just gonna put that off to the side, and then we're going to flip it over, and we'll begin by taking off the back plate here and the VRM heat sinks and the PCH heatsink. All right, now I think I got all the screws out for the other VRM heatsink. So let's see if we can take this off. Beautiful. All right. I just put this off to the side. Now we have one more heatsink down here on the bottom. This is for the PCH. So we're going to go ahead and get that off. All right. Whoops. All right, so there are the screws for the PCH. And look at that. That's a chunky heatsink. So this is a relatively decent board. I mean, it's 180 bucks brand new. So almost 200 bucks brand new. And like I said, it's literally in brand new condition. It came with the stickers, it came with all the screws. Whoever sold it or whoever returned it, they didn't return the antennas. But yeah, I mean, it is, there's not a speck of dust on this board. Like, it's in excellent condition. The PCH is beautiful. All the power stages here, everything is like brand new, immaculate. So very nice little board. Next, I'm going to remove the Wi-Fi card here. So let's go ahead and take that out. And as you can see, the Wi-Fi card, the module, it's literally just a like a PCIe M.2 connector. It's like double keyed. I don't know if it's E key, A key. I don't remember the names of the different keys, but yeah, so that's it. 2 antennas in the back. I'm just going to put the screws back in just so that way I can hang on to them. All right, so we're almost there. Let's go ahead and pop out this coin cell. Oh, I don't know. This is an interesting coin cell socket. There's like a little piece of black plastic in there. I don't know how that comes out, but it's keeping it locked. Yeah, there's a little, I don't know if you can see it. It's hard to see, but there's a little piece of black plastic that acts as a lock. And just set it down carefully, and then you can finally release the battery. So we're going to take the battery out and just put it off to the side. And then let's just take a look around, make sure there's nothing else that we can remove. Maybe I'll take this M.2. This is like a little M.2 keeper, just keeps it in place. So we'll just put that off to the side because it is plastic. We have another one here. So we'll put that off to the side because that has plastic on it. Let's see if we can get this off. Yeah, so we'll take this stand off here as well. I'm just removing as many components as I can. Any kind of like plastic components, because we're gonna need to get this board real hot in order to take the socket off. Now, a lot of these components over here, they're not gonna see too much heat, but at the same time, just as a precaution, I want to take as much off as I can, not only to protect it, but also to remove thermal mass. So all the heat sinks came off on the VRM stages and whatnot. That's to remove a bit of thermal mass, so that way we don't have to worry about it absorbing the heat and wicking it away. Next, we're gonna take the bottom and we're gonna take this this little brace here, this little support bracket, and we're gonna pull this off. Now, I'm going to try to reuse this to keep the board straight, but I want to see real quick if I can remove this plastic underneath first, because I want to use this as a stiffener to keep the socket stiff, because this would work very good for keeping it stiff while I reflow the socket, but it has this plastic coating underside. So I'm going to take a razor knife and I'm going to see if I can't pry this off and then reapply it. So I'll be right back. All right, so I was able to get it off cleanly. And the way they punch this metal, it should be safe just to push back down. I'm looking at it here now, and there's no like sharp corners or whatever. They rounded it off really good, so I don't have to worry about it digging into any of these traces here. But yeah, this is going to help keep the PCB straight when I go and add heat to it, because we're going to have to heat it up to like 200 degrees or whatever it is. So I'm going to get this back on now and find a way to secure it. All right, so I of course, am a hoarder of any kind of parts or whatever that I find or I think might be useful, and that includes screws. I love screws, so so I found a whole bunch here that'll work, and it took me a minute to figure out where I put them, but I finally remembered where I put them. Um, so yeah, we're gonna go ahead and I'm just gonna see if I can find some washers to go underneath here, because these are just barely big enough to hold the plate on, and then we'll go ahead and get started. All right, another thing I wanted to do is just see if I had a nozzle big enough. This is a 50 by 50. I'm not a big fan of the design, like the way the airflow gets blocked off. And kind of, I don't know, it's weird. It's a weird design, but it will work perfect for this. So 50 by 50 will fit around this socket perfectly. The thing we want is we want to get heat into the socket, but not a bunch of air, because hot air will oxidize and basically destroy the socket. We don't want to destroy it. We just want to heat it up enough to get it out in one piece. Now, like I said, this should be lead-free solder, so we'll see about that. The new sockets I have, they're Lotes, and they're leaded solder. I don't know if they come that way or if the seller like reballed them and put leaded solder on them, but we will find out here shortly. But yeah, they're leaded, so they should be a lot easier to solder back on. All right, so I found some washers, and they're pretty big, so they should work pretty good to keep the board stiff. You just want to make sure if you ever put washers down on a board, you put the sharp side up, because it will dig into, especially when there's like traces around there, because it will dig into these traces and it will cut them up and destroy them. So the way they make the washers is they stamp them out of a sheet of metal, and so the sharp side is always going to be the side that they stamp towards, like the way they stamp towards. So just make sure that you can kind of feel it with your fingers, but one side is rounded off and nice and smooth, and the other side is like rough around the edges and has a bit of bite to it when you touch it with your finger. Make sure that side goes up, because you will damage the traces around your socket. So, but yeah, just want to do that real quick. Make sure these are on pretty tight. All right, so that's not going anywhere. This should be perfectly stiff and should be great to remove the old socket and put the new one on. So, all right, guys, so you can see, sorry, standing up, you can see my little setup here. So we got the motherboard on the preheater that we just showed off the other day. I have my hot air nozzle on top, just free enough to kind of wiggle back and forth. It's about, I don't know, 5 millimeters off the board. We covered all the components with Kapton tape. We made a little bridge right here to keep heat off of the memory sockets. Same thing with the VRMs, just and the capacitors here. Just put some Kapton tape over those, and then have another little like metal shield right here covering this set of VRMs. And yeah, any little resistor, any little capacitor is all taped up. There's a little piece of foam right here that I removed, and then I put some more Kapton tape around the one side here of the M.2 connector to keep that from getting too hot. I don't know, this should be far enough away, but maybe I'll put some Kapton tape on the PCIe little tab here, just to keep that from getting hot as well. So anything plastic is pretty much covered, and yeah, the board was too big to fit obviously in the little vise section here, so I'm just kind of resting it down. In fact, I'll just show you guys real quick. So we move the nozzle out of the way, and you can see I just have it laid on top of the hot plate. Careful not to knock off any components on the underside of the board. So just carefully laying it down. And then carefully moving this into place. And yeah, that's pretty much it. So I think we're pretty much good to go. Just want to double check and make sure that I have everything set up well enough. Make sure that my socket's centered, and then I'm going to go ahead and put some flux underneath the socket, and then we'll go ahead and start filling her with some heat. So I just wanted to show you guys. So we have our hot plate station right next to it. So this is the front of the motherboard. You can see everything covered and capped on tape. So got everything taped off rather nicely. Got our hot air gun off to the side. Got our flux right here on the table. And these are all the heat sinks and whatnot that came off the board. So we're gonna go ahead and put some flux underneath the board, and then we will get into the reflow. But I just wanted to show you guys that. So this is where all the stuff happens, all the projects and whatnot. And yeah, it's a little crazy, but this is what I do, man. I've been trying to learn electronics repair for a long time, so just want to show you guys this. So that's the motherboard right there. All right, let's get cracking. Gonna go ahead and just put a bunch of flux around the socket here. I'm not gonna put it on, well, actually, yeah, maybe I will. You don't always want to put the flux around all the sides, or at least you want to leave a little bit of a gap, because you want to have some airflow, but there'll be airflow from the pins here, and we're just gonna float flux on top. So we just want a lot of flux. All right, so there we go. We got plenty of flux on there, and we're gonna switch over here real quick. All right, so here is our heating station. So we're gonna turn it on. Oh, come on. Oh, maybe not. No, I disconnected. All right, well, anyway, it's running. Looks like we're back. Let's see, are we back? Yeah, we're back. All right, so we're gonna switch to the set temperature, and I'm just gonna set it to like, I don't know, maybe 230. All right, so I set it to 230. Yeah, sorry, my camera is being a little lame with the internet. But yeah, so we got it running. We're gonna turn our exhaust fan on. Okay, so we can start pulling some fumes out. Just gonna angle it towards the socket there, and then we will. Not gonna turn on the heat gun yet. We want this to come up in temperature. So it's, yeah, it looks like it's still frozen, but it's around 159 degrees. Let's see, is it back? There we go. So yeah, 170, climbing up pretty fast. And we're just gonna let that climb up for a little bit. And then we will put our iron, or not our iron, but our hot air gun over the top. And you can see the flux is already beginning to liquefy. So let's see. Let's switch back. So you can see there, the flux is beginning to liquefy. It's just starting to heat up. Again, we have everything covered, all the chips and stuff in the vicinity of the socket. And yeah, I'll get back to you guys in a little bit. Get back to you as soon as we start getting some heat into the board here. And then we will go from there. All right, now because I'm in an enclosed space, and there's a lot of flux on the board here, I'm just gonna wear a mask over my face so I don't breathe in the fumes, because you do not want to breathe in flux fumes. So I do have my my little extractor. This does pull a decent amount of air. It doesn't pull enough. I need to get like a shroud for it, but it's gonna help out to pull some of these fumes, and I can kind of direct it over the board here. It's gonna obstruct the view, but that's the best I can deal with right now, so we'll just have to deal with it. All right, so I have my thermal camera here. I'm just taking a look at the board, and currently right now it is only at, it's only about 54C. Yeah, about 53, 54C. So I'm going to allow this to heat up a little bit more. I have the hot plate set to about 300 degrees Celsius. And we're just going to wait for the board to come up in temperature. All right, so we got our probe in the center here, and we are about 75 degrees Celsius. 73, 66, 67. All right, so about 70. So we're getting there. I don't know if we can get any more heat into the board, but that's where we're at right now. Okay, for whatever reason, my capture card keeps freezing, so I hope you guys can see me okay. It wasn't working earlier, but yeah, so you got the board up here. Currently at 320 degrees Celsius. We checked the top of the board. It's like 70 degrees Celsius. It's kind of coming up. I think I might try to crank it a little bit more, but that's probably as much heat as we're going to get into it. I mean, it's hot to the touch, but I don't know. We'll see. Maybe I'll crank it just a little bit more. All right, so we're like right at 80C. I'm just gonna let it rip, because that's about as high as we're probably gonna get. I have the bottom set to 360 degrees Celsius, and it tops out at 400. So obviously this board is too big for this hot plate, and it's sinking a bunch of heat. Plus I have my air conditioner running in the background to try to keep the room cool. So that's the best we're going to get. So we're going to place the nozzle over the top here, and I'm just going to align the board just a little bit, and let's go ahead and turn it on. Now I'm just going to give it full air, because that's pretty much all we can do, and then we're just going to monitor the socket and wait till we start seeing bubbles. All right, now I put it flush on top of the board. The washers are acting as spacers, which is probably a good thing because it's allowing the hot air to flow out. So it should be good. We'll take a look at it here in just a second. So here you can see I have it on top of the washers there. And we will go ahead and pull it up here in just a second and take a look at the chip. Or not the chip, the socket. Alright, so I just checked it with my thermal camera and we're just over 200 degrees Celsius on the board itself. Right where the nozzle is. So I'm going to pull it up just a little bit and I'm going to take my tweezers and see how stuck on the socket is still. Okay, we're still only at like 230 C and I'm beginning to smell the flux start burning, start smoking. So I'm going to pull it up again and I'm just going to take a look at the socket underneath and see how we're doing. Alright, sorry guys, I didn't record it because it was a pain in the butt, man. I put as much heat into this thing as I possibly could and it still wasn't enough. I had to pull the socket off in like sections. It was so glued down to the board because I couldn't get enough heat into it. So I'm going to try to invest in a hotter hot air station. But let me show you guys real quick. All right, so this is the socket and it looks like it's intact. I did have to pull up on it, so I'm hoping I didn't damage any of the pads, but from what I see, it looks good. It doesn't look like there's any damage, but we won't know completely until I start putting leaded solder on. So we're gonna go ahead and do that now. I also have my soldering iron that I just turned on, so we're going to wait for this to heat up, and we're going to put some leaded solder into this board so we can get the heat out of here. And actually, I'm going to zoom in the camera so we can see what's going on here. If there's anything that I would go redo, it would probably be to not only use more heat, but to use either more flux or a different kind of flux. This flux pretty much dried up from the hot air and kind of prevented me from working on the board. But as long as we got the socket off in one piece, we should be good. And you can see just how much lead-free solder is on this thing. It is a shit ton. Right. There's like little bits of plastic still in the still on the socket here. Like little remnants of it. All right. So that's good. So we got lead-free or leaded solder in here now. We got a whole bunch of it. So I'm going to clean up these little solder balls right here. And then we're going to wick the pads and clean the pads. So I got my trusty BUF desoldering wick. I bought some flux from these guys that I really liked a lot. So I ended up buying their soldering wick. This is rosin or flux soldering wick. And it was cheap. And when you buy wick, you just want to buy a huge roll like this. You go through so much of it, you might as well just get a massive roll. Those little dinky rolls have like nothing in them, and they're so much more expensive than just buying one of these giant rolls. But yeah, so what we're gonna do here is we're just gonna get the solder off these pads using our BF wick. And the board is still pretty hot, so it should take the wick pretty well. I still have the hot plate underneath set to like 300 degrees Celsius. So it should be pretty good. That's why I didn't cut it. I have the whole wick here, and I'm just steadily going down it. I might need to cut it at some point. As we get further down. But we're wicking away a good amount of solder. Alright, now it's starting to get stuck, so I'm going to go ahead and chop it off and then grab a new fresh piece and use that. Alright. Gonna clean my tip here. And we will start over again with a fresh piece of wick. Looks like my board's starting to cool down, so I'm going to crank the temperature back up to 400. And we're just going to go nice and gentle. You don't want to apply a lot of pressure. The wick will do the vacuuming. You just got to kind of move your soldering iron around. I just do like a little circular motion, and that is usually good enough to get the solder up. once it starts sticking to the board, then I know there's not very much solder left. And also the temperature is probably a little on the low side. But since I cranked it up, it seems to be doing pretty well, so. Alright. Going to cut off that piece. I should be wearing gloves too, because I'm starting to get flux on my fingers. And you don't want to get this you don't want to get this stuff on you. It's definitely not good for your health, so that's one of the reasons why I'm wearing the masks. I have 2 masks on top of each other just to make sure that I'm good and filtered. I see one pad here that might be a little messed up. But so far the board looks pretty good. I don't see any damaged pads. So I think we should be okay. Just gonna cut off one more section here and then I'll finish up, clean up, and then I'll show you guys the finished results from desoldering the socket. Because it's a trip, man. That I had to rip that socket into like 3 or 4 different pieces. It came off in like 2 big chunks, but you can see where it cracked in like 3 or 4 different pieces. Because I was like, why is this thing not coming up? I'm like, dude, I'm at like 250 degrees, 300 degrees Celsius on the outside of the nozzle. I had my machine set to 500 degrees, and I had the bottom hot plate set to 400 degrees. So I'm like, all right, well, like if it's not going to come up with this, I don't know what is going to do it. So I was like, let me just give it some help. I might rip a few pads, but that's $30 down the drain. I'm not too worried about it. And I can fix the pads too. I have the stuff to fix the pads. So figured, well, whatever, might as well. And yeah, so we're done with the solder removal. And we're done wicking. Now we just need to get, I have some like little pieces of junk still on here. There's like leftovers of a little pin. And I see like a little piece of plastic here. Just want to make sure I get rid of all that. Now, even though I have the hot plate set to like 400 degrees, the board itself really isn't that hot. So I'm just gonna go with it. This is gonna take a few Q-tips, so. But yeah, I just want to squeegee it up, and you can see, I don't know if you guys can see that, how dirty that Q-tip is. That is all burnt flux. There's not really a way around that when you are desoldering a massive socket like this, because it takes so much heat that the flux is always going to burn. So like halfway through when that socket broke on me, I just went ahead and added a shit ton more flux to the board just to make sure that you know, there was enough like lubrication for the solder to flow. Because that's one of the uses of flux. It allows the solder to flow. Without the flux, there's going to be way more surface tension, and the solder is not going to want to come apart, and it's going to it's going to oxidize, and there's all kinds of stuff. You get all kinds of issues whenever you don't use enough flux. And even though I poured a bunch of flux into that socket, I probably actually could have got away with using a lot more flux. But it's been so long since I've removed a socket on a motherboard that I figured I was good. But then I realized probably not. All right, so this is boring. I'm going to pause here and then I'll finish cleaning the board and then I'll get back to you guys and show you the results. The one thing I will show you guys, so I have this box of Curad alcohol prep wipes. This is only 70%, but when I'm doing a bulk job like this whole box, it's a 100 pack. These are $1.25 at the dollar store. So now these aren't very big, but if you take 2 of them and stack them up, they actually have a lot of cleaning potential. So while they're more expensive than using Q-tips, and they have a lot of water content, they still work for cleaning. So if you like are sick of going through a million Q-tips and you just want to get it done a lot faster, you can use these alcohol prep wipes, and you can see just how much, you see how like yellow they are. So I mean, it's picking up way more flux than a Q-tip ever would. And there's 100 of them in the box for $1.25. That's what I was saying about going to the dollar store and getting a lot of my supplies from the dollar stores, is they're just, you know, your consumables, it gets expensive, man. Once you buy enough pairs of gloves and wipes and alcohol and Q-tips and solder and flux and, you know, so forth, so on. So wherever you can save money, you know, yeah, it's not the like professional thing to do by using 70%, but like you can see already, man, these things are really starting to make a difference. I think like maybe 1 or 2 more of these and I should have most of, if not all of the flux off the board. So, and they don't really leave residue like Q-tips do. I mean, they do leave a little bit, but it's not like a Q-tip. This is like a weaved pattern, so they hold up a lot better. All right, so as you can see, it takes a little bit of patience, but you know, if you do it like, you know, 5 or 6, 7 times or whatever, go over it a few times with that the alcohol pads, the results are great. I mean, the board has like pretty much 0 flux on it now. It's nice and clean. You can see every pad. I could maybe go over it with 1 more pass, but it's good enough for me. I mean, it doesn't have to be perfectly clean. Plus, when I remove this capped on tape, there's going to be flux underneath the capped on tape too. So I'm not done yet. We still have to put the new socket on. So, but I just wanted to show you guys, it does a really nice job. All right. So let me just show you guys the socket here real quick. Right, so here's the microscope, and yeah, it's not looking too hot. So here's a third of it. And you can see it didn't melt. And the solder did melt. You can see the solder melted. But man, was it ever a bear to pry. So like that was a cold spot right there where the solder wasn't melting. I had to kind of peel it off the board. And you can see there's a little bit over there too where the solder wouldn't melt. So I don't know if maybe they just enough flux didn't reach it. You can see here we got a couple like pins that got bent over or something happened there with that solder. It's like 3 of them. And then you can see the crack right through it. So it almost split into 3 pieces. And then there's like a little piece of plastic there covered in flux. But yeah, so you can see all the pins there. That's the damage that we had. And yeah, so that's basically all this right here. So you can see our little pieces of the socket. Now I'm glad that I didn't rip any pads, because that would have been really bad if I ripped pads. But it was either go or no go. I had smoke pouring up out of the unit, starting to stink up the room, and I just wanted to get it over with, get the heat out of it. It's 1 a.m. here, so I just wanted to get it done. But anyway, here's our board. You can see nice and clean, nice and dry. You see a couple little teeny bits of flux around the chip. But yeah, it looks like it's in good shape. So let's put it under the microscope now that it's cooled down. And let's take a look at our socket. So you can see there's here, where is my pointing device? Sorry, let me grab a pointing device. So you can see, looks like there's either a little bit of damage to these or a little bit of solder still on them. I'm not sure. That one in particular looks kind of weird. But then we go around to the rest of them. Those are all nice and clean. Nice, beautiful, clean pads. Looks like we have one gray pad right here. So this is a pad that is oxidized. What we can just do is take our tweezers and scrape it, and you can see it came back to life. We have a couple other pads that are turning a little bit gray. Like those. I don't really see any other ones. But yeah, so it looks good. So just going over it. There's one pad right there that's still got a little bit of solder on it. That's not a big deal. And just looking over it some more. But yeah, it looks good. Like the solder mask. So the solder mask, which is this, you know, black coating on the PCB, it looks good. It's perfectly intact. There's no scratches, no scarring, nothing like that. It's nice and clean. Everything looks clean. You can see in the middle here, all that looks good. The only concern I have is like this one pad right here looks a little funky, like it's like a little recessed or something, or like it maybe might be a little loose. If that's the case, then what we'll do is I might not touch it. I might just leave it alone. That, or maybe I'll put a little bit of UV epoxy underneath. I think there's just solder on it. I think that's all it is. It's probably just solder, because it doesn't seem to be going anywhere. And then we have a ground pad right next to it. And then I just see one pad that I kind of missed. This one right here that's got a little bit of solder on it. It's just a little domed. But other than that, everything looks good. Looks solid. So let's just take a quick look at our replacement socket. So here is the underside. And let me just focus real quick. So you can see the lead balls. Now they're not very big, so I don't know how well they'll drop. At least they don't appear to be very big. But hey, if they drop and the socket works, then it works. Let's take a look at this cover. Alright, so that's the top side. And let's focus. So that's our brand new socket. Everything looks good, looks solid. All the pins are in perfect condition. This is a Lotes brand socket. Lotes. So let's just Put it back to the table. All right, so this is our brand new socket, and our cover. Where does our cover go? How does our cover go? All right, so our cover is back on. I just want to keep that on because obviously you don't want to damage any of the pins. Looking for like a pin 1 marker. I do see this little hook thing here, and I see that little tab right there. So you see underneath the here, I'll put it underneath the microscope to show you guys a little bit better. So where are we at? Where are we at? Where are we at? Right here. So this little area right here, you see that little indent or that little protrusion? That lines up with this right here. So that's how we know. And you can see A1. So A1 is probably pin 1. There's our arrow there. And when we line it up, it matches up perfectly. So when we go to solder it on, we'll just lay it in like that. And you can see there's quite a bit of space between this white line and the socket. Well, you got to remember there's two markings. There's one underneath it that's a little bit more precise. So whenever we go to line it up, we'll just kind of look underneath it, and we'll make sure everything's good. So just go back to the table. So I'm not going to do the soldering of the new socket today. We're going to save that for part 2. So I don't mean to keep you guys in suspense, but like I said, it's late here. I don't want to do it all in one shot. I want to be like rested. It was already enough work today between the cameras and a bunch of other stuff I was working on. So anyway, I'll catch you guys later. Hope you enjoyed the video, and I'll see you next time. Peace.